Hello guys, welcome to this video. I'm Komang Triana, mathematics education student from Ganesha Education University. So, I made this video to complete one of the assignments in the English format course. In this video, I will explain to you about vector, especially projection of vector. So, without any further ado, let's begin. The goal of this video is to determine the projection of one vector onto another. So how we can imagine projection? I will give you example. Look at this picture. There is table in the ground. So if there is sunlight, it will shade the table on the ground. We can imagine the shadow as a projection of table onto ground. So if we want to project vector u onto vector v, we use this notation here. Vector u is being projected onto vector v. Looking at the graph here, we're projecting the green vector u onto blue vector v, and the projection is the gray vector, which we call vector w sub 1. So, to emphasize this, the projection of the green vector onto the blue vector is the gray vector here. One way to think of a projection of one vector onto another is if we were to have a light up here and it was shining down on the green vector, the projection of u onto v will be the shadow that this light produces. We can also think of the projection as the vector component of u along v. The next thing I want to mention is the vector w sub 2 is called the vector component of u orthogonal to v, and we can find w sub 2 by taking vector u and subtracting vector w sub 1. Please notice that the purple vector is orthogonal to the blue vector, and vector w sub 1 plus vector w sub 2 does equal vector u. Looking at the second diagram, if we had a light up here and projected vector u onto vector v, this light will produce a shadow in the opposite direction of vector v. Again, the projection would be this gray vector here, vector w sub 1. So, the projection doesn't necessarily have to be in the same direction, but it will be a scalar multiple of vector v. On the second sketch, here, vector w sub 2, or the vector component of u that's orthogonal to vector v, would be this vector here. So again, the highlighted gray vector would be the vector component of u along v, and the vector component of u orthogonal to v would be vector w sub 2, would look something like this. Again, notice it's orthogonal or perpendicular to vector v, and vector w sub 1 plus vector w sub 2 will equal to u. Now, let's go ahead and take a look at the formula that will allow us to find the projection of u onto v. If u and v are non-zero vectors, so that the projection of u onto v is given by this formula here. Notice that the projection of u onto v is going to be a scalar multiple of vector v. The dot product will be a numerical value, and so would the magnitude of vector v squared. We'll take a look at an example in R2. We want to determine the projection of u onto v given these two vectors and determine the vector component of u that's orthogonal to v. So here is our formula to determine the vector projection of u onto v. It's going to be equal to u dotted with v divided by the magnitude of vector v squared times vector v. Let's go and determine the dot products. So u dotted with v is going to be 3 times 4, that's 12, plus 1 times 2, that's 2, divided by the magnitude of vector v squared. Remember, the magnitude of vector v would be the square root of 4 squared plus 2 squared, but if we are squaring the square root, we are just going to have 4 squared plus 2 squared. And we are going to multiply this scalar by vector v, which is the vector 4, 2. Let's go ahead and determine what this scalar would be. 14 divided by 16 plus 4, that's 20. this fraction simplifies. It will be 7 over 10, so we multiply this. We are going to have 28 over 10, that will be 14 over 5. 7 over 10 times 2 would be 14 over 10 or 7 over 5. And we'll go ahead and let the projection of u onto v be vector w sub 1. Now we want to determine the vector component of u that's orthogonal to v. We'll go ahead and call that w sub 2, and that's going to be equal to u minus w sub 1. So we are going to have vector 3, 1 minus the vector 14 over 5, 7 over 5. So vector w is going to equal 3 minus 14 over 5, that will be 1 over 5, and the y component will be 1 minus 7 over 5 or negative 2 over 5. So again, here is the projection of u onto v, and then here's the vector component of u that's orthogonal to v. Let's go ahead and take a look at the graph of this. We are projecting the green vector onto the blue vector. The projection of u onto v would be here. The orthogonal component or vector w sub 2 would be here. And we can see that w sub 1 plus w sub 2 is going to equal vector u. So here's a nice illustration of what we just found. The projection highlighted in yellow and the orthogonal component in purple. Okay, that's going to do it for this video. I hope you found this example helpful. Thanks for watching and see you in the next video.